Okay, let's finish talking about arithmetic operators. So the only one that I have not discussed yet is the modulus. And in order for us to really understand what modulus does, even though it's pretty simple, we need to finish talking about division first. So division is just like we learned in elementary school. Nothing much has changed, except that here we have two types of numbers. We have integers, which are whole numbers, and we have doubles and floats, doubles or floats that are real numbers. So basically, when we're going to have integer division versus real division. And the difference between those two is integer division is what you did when you were in grade 2, and real division is what you did in later years. That's pretty much it. Basically, if one or both operands in a division are real numbers, the result will be a real number. If they're both integers, the result will be an integer. So integers can have remainders. Can have decimals. So we'll end up with remainders. So if you had double A and B and int x and y, first of all, this is what we would have in memory. So we would have A, sort of a bigger number. It's going to be saved, remember, 7.0000, probably with some 1 at the very end. And you're going to have B. B is also going to be saved in a huge spot. So 2 is going to be 2.00000 all the way out. And then we're going to have X is going to be precisely 5, and we're going to have Y, which is going to be precisely 2. So now what we want to do is we want to print out, so you recall print ln, it prints it to the console at the bottom. So go ahead and actually code these in processing. So define your variables and try to go ahead and write these print statements. So this is going to print to the screen the result of this operation. So if I have a real number divided by a real number, 7 divided by 2, I'm going to get a decimal, so it's going to be very exact. It's going to be 3.5. If I have a real number, A, which is a double, divided by Y, which is 2, because it's a real number divided by an integer, I would still get a real number, 3.5. If I have an integer divided by a real number, I would still get a real number in response. So x divided by b, x is 5 and b is 2, so this is going to be a real division, 2.5. This is the only case that I'm going to have an integer divided by an integer, and in this case this is going to be an integer division. So just as you learned in grade 5, if you have 5 divided by 2, we didn't know decimals back then, and integers don't know decimals. So 5 divided by 2, 2 goes into 5 2 times. So the answer is actually 2. The answer is an integer. Now there is a remainder, right? And that's where modulus comes in. So right in here, if I go ahead and say x modulus y, the result is going to be 1, because modulus checks for the remainder. So modulus operator returns, and the term returns, you should use it as gives for the time being, returns the remainder of an integer division on its operand. Integer division is key. So if you have two doubles there is no remainder. Therefore, you cannot use the modulus operator for two doubles, or you cannot. You can also not use it between a double and an integer. There's not going to be any remainders there because it's real division. Wherever you have integer division, you're going to have this. So if you have int x equal 5, y equal 2, and z equal 4, I'm actually gonna, so this is the memory diagram. X is 5, y is 2, z is 4, and we have result. And what is result to begin with? They're all integers, right? But what is inside the result to begin with? Garbage. So we can say result equal x modulus 2. That is, x is 5, 5 modulus 2 is 1. So 1 is going to be placed here. Then we say result is z modulus 2. Z modulus 2 is 4. So 4 divided by 2. That is, so the modulus is 0. There is no remainder. Then we have y modulus 5. So y is 2 modulus 5. So if you wanted to do this division, it would be y. So y is 2 divided by 5. So how many 5s do you have in a 2? 0. So the remainder is actually 2. So if you ever wanted to see if, for example, a number is divisible by 2, you could do that number modulus 2 and you'll have your answer. The next topic I want to cover is implicit and explicit type conversion. This is not a huge topic in this course, but it is useful to know that you can convert any processing type to another type for an instance of time that is inside of one line. Basically, you could say that, let's say we have double x as 10.5, and we want to store the value of x inside an integer. This cannot happen simply because of the fact that the double is too large to fit inside an integer. In this situation, what we do is called typecasting. So you would use the int inside parentheses, and that would translate x into an integer in order to fit it into y. But x is not made into an integer. So if this is the memory diagram here, x is actually being saved in memory as something like this: 10.5000000. You know, there could be like a 1 or 2 at the end. Remember, it's not precise. When you try to typecast x as an integer, and you put it inside of y, y is going to have 10 inside. So that's 10. And you basically cut off the rest of the decimal value of y, and you don't care about the rest of it. Notice that x has not changed. So x doesn't change into an integer magically. It's just that for that line, it gets treated like an integer. Let's see another example of this. So if we have int x equals 4 and y equals 7, and we have double ratio, here we have two integers, but because we are typecasting x as a double here, the result is going to be a double. So this actually turns into a double division, or real division. So if you have x divided by y, that is an integer division. Since here we're doing the typecasting, this is actually now a real division. So to illustrate this a little bit more, if we have int x equal 4 and y equals 7, and I can have int, actually I can have double ratio equal x divided by y. This is going to look this way. So x in memory is 4, y in memory is 7, and ratio, which is a double, so I would have 4 divided by 7. And that's going to be an integer division, the result of which is going to be placed inside of a double. So this is going to be 0.00000. So the result of this is 0, and it's going to be placed inside a double. Now, if I were to do this, let's say I have int x equals 4, comma y 7, and I have double ratio equals, let me show this with another color. So I would typecast and I would say int, they're integers rather, I would say double x divided by y. Now the result of this is going to be into real division, so the result of this is actually going to be whatever 4 divided by 7 actually is, which is, you know, around 0.5, more than 0.5, right? So let's say 0.57. So what we're going to have, still I'm going to have x as 4, y as 7, and ratio, now it's going to be 0.57, because this is a real division, that's an integer division. So going back to the slides, this type that I'm showing here is actually called explicit type conversion. It is explicit because we are actually showing it here. Okay, there is one quick topic that I want to discuss before finishing this lecture, and that is a really cool shortcut in processing. It's the same way in Java and C++ as well. So let's say if you have int a equal 10, and if you wanted to do any sort of an operation, so let's say you wanted to say a equals a plus 3. So there's a lot of writing. You could actually save on writing, and this is the same way. Instead of this, you could write it as a plus equal 3. So the plus equal is an operator that is used to denote adding something to adding a variable to itself. With this, we also you also have so the results for both of these statements is 13. I just randomly picked that. It came to 13, but yeah. So so you have plus equal. We also have minus equal, multiplication equal, division equal, and modulus equal. And they all work the same way. So for example, if I have right now, so let's say a is 13 at this point, if I said a minus equal 5, then A would become 8. So this would save you a little bit of writing. And that's it. We are done with the arithmetic in processing. Thank you.